In this video, we're going to discuss the y-intercept and x-intercept of linear functions. The y-intercept of a linear function is where that linear function crosses the y-axis. The x-intercept is where the function crosses the x-axis. So let's say I draw any random line. The y-intercept of this graph would be right over here, and the x-intercept of this graph would be right over here. How do we find the y? Let's start with the y-intercept. How do we find the y-intercept? We don't have a graph. We can't just look at the graph and see where it is. If our equation is in the form y is equal to mx plus b, it's in slope-intercept form, then m is the slope, we already discussed that, and b is the y-intercept. So whenever an equation, a linear equation, is solved for y, we have y on one side of the equation and everything else on the other side. The constant, the number that's not attached to the x, is always going to be our y-intercept. Let's see if that's true. Let's say we have the equation y is equal to 5x plus 3. Let's graph it on the calculator and see if that graph actually crosses the y-axis at 3. We'll go into y equals, and we'll type by y1, 5x plus 3. And graph. And if you count on the y-axis, 1, 2, 3, you'll see that the graph crosses the y-axis exactly at 3. And this is going to be true whenever we have a line, that we're graphing, the y-intercept will always be this constant number. But let's say your equation is not in y equals mx plus b form. Let's say you have the equation y minus 3 is equal to 3 times x minus 2. So either you could put it in y equals mx plus b form. Let's do that. We'll do that first, and then we'll see how else we could solve this. So we have the equation y minus is equal to 3 times x minus 2. So on the right-hand side, we'll distribute the 3. Y minus 3 is equal to 3x minus 6. We'll add the 3 here and add the 3 here. Y is equal to 3x minus 3. So we're assuming in this case that our y-intercept is negative 3. A number is always attached to the sign that's before it. So you don't want to think that the y-intercept is positive 3, it's negative 3. It's attached to the sign that's before it. In this case, it's a negative 3. But how else could we solve this equation to find the y-intercept? If you'll notice on the graph, on the calculator, the equation that we graphed before, y is equal to 5x plus 3, it's a different equation. It's a different line. But if you see that wherever it crosses the x-axis, the x-coordinate of that point is 0. And wherever any graph would cross the x-axis, if it crosses it over here, then the x-coordinate is 0. If it crosses over here, the x-coordinate is 0. If it crosses over here, the x-coordinate is always going to be equal to 0. So, we can solve this equation, y minus 3 is equal to 3 times x minus 2, if we plug in for x. If we plug in a 0, then we'll get our y-intercept also. Let's do that. Y minus 3 is equal to 3 times 0 minus 2. Let's simplify this. Y minus 3 is equal to 3 times 0 minus 2 is negative 2. Y minus 3 is equal to 3 times negative 2, which is negative 6. Then we're going to add 3 and add 3, plus 3 and plus 3. Y is equal to negative 6 plus 3 is negative 3. So when we solved it like that, by plugging in 0 for x, we got the same thing. We got that our y-intercept is going to be equal to negative 3. So that's an important thing to remember, that wherever a graph crosses the y-axis, the x-coordinate of that point is going to be 0. So to find the y-intercept of any graph, just set the x value of that equation equal to 0 and solve for y. Now let's discuss the x-intercept of a graph. where does a graph cross the x-axis? Let's say I graph any random line over here. You'll notice that where it crosses the x-axis over here, the coordinates of this point is 4, 0. Let's graph another line. Let's graph a line over here. The coordinates of the x-intercept of this line, the one in orange, is -2, 0. And let's just graph one more. The coordinates of the x-intercept of this line are 7, 0. Now if you notice, whichever line we graph, any line that we graph, the x-intercept of that line, the y-coordinate of that point is always going to be 0. So let's say we have an equation. We have the equation y is equal to 16x plus 5. We already discussed that in this case, the b term, in this case it would be positive 5, is the y-intercept. But the equation doesn't tell us straight out what the x-intercept is. But if we notice from the three lines, the green line, the orange line, the light blue line that we just graphed, wherever a graph or whatever a line crosses the x-axis, the y-coordinate of that point is going to be 0. So if we just plug in for y, if we plug in 0, we could solve for what the x value would be at that point. So let's try that. 0 is equal to 16x plus 5. And let's solve this for x. So we're going to subtract 5 and subtract 5. 0 minus 5 is -5. It's equal to 16x, because plus 5 and minus 5 cancel out. Divide by 16 and divide by 16. X is equal to -5 over 16. And if we want, we can have the calculator tell us what is -5 over 16. -5 divided by 16 is -0.3125. So this line would cross the x-axis somewhere over here. The line would look something like that. Now, how do we know? First of all, how do we know if we got it right? And second of all, is there an easier way to do it? Because finding the y-intercept is very easy when your line is in y is equal to mx plus b4. But finding the x-intercept isn't as easy because the equation doesn't say straight out where the graph crosses the x-axis. But we can have the calculator tell us. Let's graph that line. Y is equal to 16x plus 5 on the calculator. Let's press graph. And we could see that where it crosses the x-axis is around where we drew our dark blue line and where we thought that it would cross at -0.3125. But can we find out exactly? Let's say we didn't solve it beforehand and we wanted to find out exactly where the graph crosses the x-axis. We can have the calculator tell us. If you press the second button, whenever you press the second button, if you'll notice when it's not clicked, the second button is blue. Then, whenever we press the second button, we're activating the little blue words on top of each button. So if we press trace, the little blue word on top of it is calc, for calculate. And if we scroll down to 2, that says 0. 0 is another word for the x-intercept. Press enter. Then they want us to find the left bound. So what we need to do is go all the way to the left of that point. Here we see there our little cursor is to the left of where it crosses. Press enter. Now they want right bound. They want us to tell them where is the right of that point. So we're on the right side of the point. Now the calculator wants us to guess where do we think it crosses. Doesn't have to be exact, but somewhere over there. And you'll see the calculator showed us right away that it crosses at x is equal to -0.3125, 0. Which is what we thought also when we solved it.